international universities is that we have little or no international students, especially in undergraduate programs. Now, admitting international students is kind of impractical, but I think what we can do is we can promote exchanges with international universities, particularly the Ivy Leagues. So I don't think IITs currently have exchanges with the Ivy Leagues. What are we doing to change that? Can we change that? And is there an alternative to increase the international exposure amongst undergraduates in the IIT?
I'm not certain if just getting exchange students would be the right way to go about it, right? Because that seems like to me a stopgap arrangement. Getting some students so that we can improve our rankings. I don't think that's the right way to go about it. So we should, we have very strong undergraduate programs. We should be able to market them, or we should be able to tell the world. And I think most of the world is familiar with our undergraduate programs, that they are very strong. So we need to find mechanisms by which we can take in those undergraduate students, right? So I think recently there has been an effort in that direction, right? That JEE, for instance, now is held in all the neighboring countries, the SAARC countries. And so the intent is to try and get undergraduate students from there. Now, unfortunately, I think it's still not going to be very easy, because all we've said is that those students will still have to compete the JEE exam and get an equivalent rank, and only then will they be admitted into our undergrad program. And since many of those students, I was in Nepal as part of the team where we were trying to tell the undergrad students there that they should write the JEE exam and come. And most of them were asking us this, how do we prepare for the exam, because we don't have the material, the resources that students in India have to be able to prepare for this exam. It's a very hard exam, and they're right about it. So I do not know whether this is going to work right away, but I think in the long run we need to find mechanisms by which we can actually get maybe not just students from the SAARC countries, but from outside also. Make it easier, right? So what is it that students find it difficult, right? Is it hostel accommodation, cultural differences? Make it easier for them to come. And in that manner, so I think having international students is a very great thing. Just getting international students so that we can improve our rankings is not the right way to do it.
Now, what I feel, I'm a fresher, so what I feel is that some of the courses are not really aligned to the JEE syllabus, because people who come to IIT have extensively studied the JEE syllabus. So if I would give an example, it's that in the physics course, there are a lot of mathematical preliminaries that are not in the JEE syllabus and are rushed through in the course. On the other hand, a lot of topics which are in the JEE syllabus get a disproportionate amount of time. So do you feel that these courses may be better designed keeping the JEE syllabus in mind? And is there any step in this direction which is happening?
No, I think that's a very good point. If you and your classmates feel that such is the case, I think we have these curriculum reviews regularly, right? So when you fill out those curriculum reviews form, make it a point that you and others bring this up. I think this is a very natural, it's a very important point. There are topics which you guys are very well versed with, which are being redone, and stuff that you are not familiar with being rushed through, right? So this is a feedback that you guys should provide, and I feel, to the instructor, so that the next iteration of this course can incorporate that, right? So there we have a mechanism of student feedback, and most of the faculty take that feedback very, very seriously. So the students should also take it seriously, and make it, it should not just be okay, we are done with this course and so we don't care anything about it. But if you really care about this aspect of it, you should provide the feedback, I think, and I'm sure it will get incorporated.
And IIT coursework is not rigid or
no, we are very flexible, right? I think, and I'm sure this applies to all faculty members. So we take the feedback very seriously. If there are such real problems in a certain course, then we would be very happy to change it.
in a class, whatever class, sorry, you take, there is a sheer diversity of students. I mean, they come from different level of understanding. And in India, we also have a linguistic differences. So how is that, you overcome that and still able to teach the material to majority of the students?
This is definitely a big challenge, and this has become, this challenge has sort of acquired bigger dimensions over the, as over the last few years, because the diversity in the classroom is now much more than what it was earlier. It's, as you can imagine, it's very easy to teach, or it's a lot of fun to teach to a homogeneous group of very bright students. It's both easy and fun, but when the group becomes diverse and the level of preparations of students are different, then it becomes more challenging. How do we bring that in? So I think one thing that at least has happened in my own way of teaching, or how I have adapted to it, is that I have in the material that I cover in the lectures, where most of the students are together, that material has, I have ended up reducing the difficulty of that material, and the students who are smarter, who are not getting challenged because of the reduced material in the lectures, they I would usually give them a different set of problems in the exams or in tutorials or in assignments, so that they can they can also feel intellectually challenged by that problem. So we do have, for the students who are at the other end of the class, who are having difficulties keeping pace even with this kind of a class, we do have mechanisms to get those students to come talk to the faculty, and if they are not able to follow something, getting additional help sessions so that they can continue with the class. So this is a big challenge, right? And having one class in which we are teaching all these students is not the optimum way of addressing this challenge. Unfortunately, because of limited resources, this is how we are still working with, having one class with 150 students, which are all very with a large amount of diversity. But each one of us has devised some small mechanism of our own, recalibrating the level of our lectures, giving additional exercises to the smarter students, providing help sessions to the weaker students to be able to manage it somehow.
Do you consider teaching as an impediment to research, or it helps you do better research?
No, teaching is great. Why? Because research is very frustrating. It's very frustrating at times. It might be months before we are able to, months or years, as Jatin might know, before we are able to prove what we want to do, especially research in theoretical computer science. So teaching is that bright spot, right? So at the end of the day, even if you were just doing research for the whole day and you came up with nothing, and you did not even teach a class, then feels like a day lost, right? So at least when you go teach, you are, or at least I feel very good, because I can talk to students, I can tell them something, I can get some bright ideas from the students quite often. So teaching is a very important part of doing research, I feel, right? I would not be able to survive in an institution where there was only research.
So would you say you borrow some elements from your research and make your teaching better, or is teaching you considered separate exercise?
No, I think they go hand in hand. I have known instances, there's a very, I've known instances where a professor, again algorithms, he got a brilliant idea while he was teaching the class, right? He was teaching a certain algorithm to the class, and during the course of the discussion with his students, he got this idea, and that resulted in a significant improvement to an existing algorithm. So that's one way, but also the kind of research that we do is quite often fairly close to our teaching, right? So, okay, the right way to think about this is that we usually teach only such courses, especially at the graduate level, which are closer to a research area, right? So, I work in algorithms, I would not be teaching a course in operating systems or computer networks because those are far away from my research area. I would be teaching courses which are broadly in the area of algorithms, and then my own understanding of algorithms and various aspects of it, various interconnections of it helps a lot in my teaching, right? So, the fact that I have done research in this area, the fact that I have spent hours thinking about these problems is very valuable when you are doing the teaching, right? Because at least for me, a student comes up with a certain algorithm for a problem. Since I have enough experience with it through research, I can tell whether this algorithm is going to be right or it's not going to work, right? And I would not be able to do that if for a different course or if I had not been doing research in that particular area. So, I think teaching and research go hand in hand. It's very important for researchers to be teaching and for teachers to also be good researchers.
So we just heard from you, you work in the area of theoretical computer science, and so it's theory as it is called. And for us experimental biologists or experimental scientists, it's a little bit intriguing and interesting at the same time. So I just, and along with students, we want to know what is this process, because in theory you have to come up with some theory on your own and prove it yourself. So what is this process for, what is this process? How?
No, it's not something completely from scratch either, right? So, it's not, so quite often the way this would work is that, like I told you about the traveling salesman problem, right? So, this is a problem that's very well studied. There are tons of papers on this problem. There are books written on this problem. I want to work on this problem. So, let's say I wanted to work with a student on this. The first thing we would do is read up the relevant literature, right? Understand, these are the things that people have already tried. These are the approaches that have worked. These are the things which have not worked. And then the first thing is to come up with a new idea, with a new approach, right, which is likely different from existing approaches. Sometimes we could see that, oh, this approach has not been taken to completion. Maybe there are a different way of analyzing the same algorithm. Maybe there is a different modification. There's a modification that I could have done to this algorithm which would have resulted in a better solution, right? So sometimes we would be able to find that. Sometimes we would, again, here this is where experience plays a significant role, right? So sometimes you would come up with a new approach, and now this is where the hard part starts. So you think of, okay, this algorithm might work, and then you spend time thinking about that algorithm, trying to work small examples with that algorithm, finding counterexamples to your hypothesis. You think, okay, this is likely to be true about this algorithm, like just as you would do in any scientific research, right? This is my hypothesis. Now you would do experiments. Now our experiments are more paper pen, right? We would try to draw some examples and see whether this works on this example, whether our algorithm works on that example, whether it does not. If it fails, then we would try to modify our algorithm. So in that sense, it's not, I would not say it's very different from experimental research. It's easier in a certain sense. We don't have to clean Petri dishes and do a lot of dirty work. We can just do stuff on paper and pen.
How do you know you're making progress or not? Are there ways you can judge in the process that you're going in the right direction, or?
Yeah. So for instance, again, I try to solve a problem, and usually we would start small, right? We would say, okay, this is a big problem. Can I solve it for instances of this kind? When let's say this graph, this traveling salesman, or the graph problem that I said, you want to find a cycle. And to begin with, I would say, can I solve this for these kind of graphs? And if I could solve it if I can get an algorithm for those kind of graphs, then I would ask myself, can I extend it to a larger class of graphs, right? So we would usually, this is how we would progress, right? We would first develop an algorithm for some special case, and then see, can we take it forward? You know, can we apply the same algorithm for a larger set of problems, for a larger set of instances. So, and you know, this is how we would know whether we are making progress, right? If you could, so quite often, you know, the special case itself that we are trying to solve the problem for has all the meat in it, so to say, right? It, you know, the challenge is right there, and if you can solve it, usually sometimes it happens that the general case is easily solved, and sometimes that doesn't, right? So our special case was really very special, and to generalize it takes a lot more effort. So again, it depends upon the particular problem we are solving, and sometimes it's easy to figure out that yes, progress is being made, sometimes it's much harder.
So does it ever happen the problem doesn't get solved?
Oh yeah, I have problems that I've been working on for the last 20 years, and
20.
they're still there in my head. Yeah, they're unsolved.
But student might not have 20 years. So in case of student, let's
Yeah.
say the problem didn't work out.
Yeah, so this is actually a challenge for me as an advisor, and I guess this is true for everyone. What problem should you pose to your student? Because it should not be very easy, because otherwise this will be a very light thesis which will not be very meaningful for the student. It should not be so hard that it takes 20 years to solve. So it should be at the right level. So again, this is where I would say experience of advisor matters a lot, right? To find the right level. Also, you know, this should match with the student's abilities also, right? You want that the student should solve this problem and not the you know, not someone else, right? That the student should be able to come up with most of the solution himself or herself. So yeah, this is very challenging. I have had instances where I gave where the problem that I gave was too hard. It's only after we started working that I realized that, oh, it's too hard, and then we had to switch to something easier. Yeah, it has not happened the other way around where I thought the problem I gave was too easy. Every problem seems to be too hard.
Let's say student is working with you and it's turned out to be a hard problem, which you kind of realize later. Some amount of time has gone by. So how do you advise student to, you know, just move on and deal with it, or, you know, or find another problem?
So yeah, so either you know, either so whatever the student has developed so far working on that problem, you know, those ideas could potentially be used to solve some slight variant of the problem, which is likely easier, right? So that would be one way of handling it. The other would be you know, even if one has not been able to solve the complete problem, one has been able to solve some special cases of the problem. Quite often there is a lot of value even in that, right? So even for this traveling salesman problem that I was telling you about, there is a special case of this problem for which people have been working and trying to solve that, and that itself has generated a lot of excitement in the research community, right? So it's a special case, and likely solution to that special case will not significantly help us solve the more general case of that problem. But you know, in solving that itself, you know, lots of new ideas have been generated, lots of work has gotten done. So you know, the big problems have lots of interesting, you know, there are complexity at many levels, and that's why they are the big and interesting and challenging problem. You know, think of you know, Fermat's last theorem. You know, to solve that, people took years and years and developed whole new branches of math just to solve that one problem. So these big problems are you know, that's what makes them exciting to work on. That there are so many different layers. You know, even if you are able to peel one layer and understand that, that is already a huge contribution.
What do you think is the impact of your research on, you know, in this area you work on?
What has been the impact of my research? So I was actually lucky to get onto approximation algorithms when the area was sort of just starting. And so together with my advisor as part of my PhD, we did some very interesting work on what's called multi-commodity flows. Um, we proved some theorems which stand till this date in the sense that they have not been improved. That has that led to a lot of research in approximation algorithms. So yeah, so we started at a time when things were still very easy. We could prove some very nice results, and they have definitely helped the field, right, in the sense that our work is used to develop algorithms for other kinds of problems, for a whole lot of other problems. So in that sense, I would say, the research that I've done has definitely had an impact on this area of approximation algorithms.
So every PhD student almost has this question when they're starting out. How would you know this is the right, I'm talking about research problem because you have to kind of identify a problem you want to work on. So how would a student know he's picked the right, the question is right for him to answer and say?
See, at least in computer science, and since I'm aware of theoretical computer science, one thing that is very important when we are choosing a problem is to look at if others are also interested in this problem. Have you chosen a problem which 3 people in the world work on, or have you chosen a problem which will be of interest to, let's say, 50 or 100 or 200 people, right? Who else has been working on this problem? What is the recent work done on this problem? I think these are very important parameters. You don't want, while PhD is meant to be a time when you get deep into research and learn a lot about some small area, you want this to still be, you want your work to be of interest to more than a handful of people, right? And to my mind, this is a very important consideration in deciding on the problem. Of course, as I said, you also want that the problem that you've picked up be the right level of difficulty, right? That in the process of solving or coming up with a solution to that problem, and this is not just computer science, I guess this is true for all sciences, right? In the process of coming up with a solution to that problem, you are able to develop some new ideas, some new techniques, some new tools. And this part, I imagine that a PhD student might not be in a position to gauge at, when he or she is picking the problem. And this is where I think the role of an advisor was very important. An advisor can perhaps, based on his her experience, give a fair idea of how interesting, how challenging it would be to solve that problem. What are the kind of techniques that one might end up developing in the process? So, yeah, I think the advisor has a very important role to play. So the student should not just pick a problem on his or her own, right? They should be talking closely to their advisor on whether this would be the right problem to work on. That said, I think the student should also exercise their own judgment by looking at, so one place where the advisors are likely to, I say, not be very honest is by, working in areas that they have been working on in the past, right? So all of us tend to, just feel very comfortable with our own areas, and we want to, just keep working in that, right? Without looking at something different, something new, and that's where a student can bring in. I think that's a point where a student should exercise his or her right on choosing a problem by saying this is perhaps something too narrow, or this is maybe of interest only to. I don't think a student will be able to say that to his or her advisor, that this is too narrow. You've been doing this, but there are only 5 other people in the world, including you, who do this. I want to do something else. But this is what I think a student should. That's the part where the student should exercise their right on choosing the problem. Once the student has identified a good problem which a lot of other people are looking at, then she should use the advisor's experience to judge whether that's a problem which is not too easy and not too difficult for it to be a PhD problem.
How would a student know theory is the right area for them to start their career in? What is it that they need to check mark in their own ability to start working in theory?
I think anyone who is, and I think this is true for all areas, right? So if they feel excited about it, right? If they, if they want to learn more about it, they enjoy doing. So theory is not different from other areas in that sense, right? That they enjoy doing, let's say it's algorithms, right? If they enjoy developing an algorithm, if they understand the arguments that go into proving an algorithm correct, proving it's competitive or whatever its bounds, if they enjoy all of that, then I think they are fine, right? Then they are ready to take up research in that. Of course, they might not have the complete background, which is usually then taken care of by doing some relevant amount of coursework in that area. But I think theory is no different from other areas in that sense, right? To my mind, the bottom line always is that the person should be excited about working in that area. If they are, then they are good enough, they are capable of doing it.
So you're in theory, and generally believed theories don't have practical applications, and more or less so in industry. And if you were to be on a spectrum, industry and theory are on the two extreme ends of the. So somebody might wonder, if there is no practical application, why do theory at all? So what would be your answer to that?
No, so okay. So to the second question on if there are no practical applications, why do theory at all? I think all I would say here is that it's usually not the case that there are no practical applications. You can only say there are no immediate practical applications, right? 15 years ago, people started talking about quantum computing, right? And there was absolutely no way that a quantum computer was going to be built 15 years ago. Even now, there's no quantum computer, or there are quantum computers which can only work with a small number of bits. But it is conceivable that in the next 20-25 years, someone might come up with, or people might be able to build a full-fledged quantum computer, right? So something that was completely theoretical and as far removed from practicality as one could imagine 20 years ago might be fully practical, and you might have algorithms, and you might have you might have a desktop quantum computer in 20-25 years, right? So that's perfectly possible. So theory likely doesn't have immediate practical utility, but it's very important to still do theory, because in the long run, all of those things that were developed some number of years ago, we are going to be using them sooner or later, right? So as far as my own research is concerned, I think many of the problems that we look at, they are very close to practice. So we look at, so with Jatin we are working on scheduling problems, and they are used a lot in computer systems. The traveling salesman problem that I told you about, it doesn't seem it's going to be very useful. How often does your mother ask you to visit 20 places? But that's a very important problem in many areas. So these points that we said, that you need to visit. So these could, for instance, be the holes that a drill needs to drill in designing, let's say, a VLSI chip or something of that kind, right? And so the length of this tour then is the total amount of moment that has to do. and quite often, these will determine the costs and the time required to produce that chip. Or, airlines use this quite a bit, these kind of routing problems. So, there are lots of applications for many of these problems. I would not say we are directly involved in many of these applications, but the results that we write, the algorithms that we produce are then used by people in many different industries to then solve the problems that they have.
I mean, it's a general question that has been put to me by several students, and not about computer science actually. Several department students feel the selecting of advisor by a PhD student little ad hoc in IITs. A student gives an exam, gets selected in a day or just few days, asked to pick advisor. It more sounds to them more like an arranged marriage than a love marriage. So why are IITs in 2017 still, have this rudimentary way of, allowing students to pick a advisor? It should be more up to date, better ways, or you can.
Yeah, so I do not know why we follow this system, honestly, so at least in our own department, in the computer science department, we don't follow this. The way we work, and I would propose this also to our own institute, that we give students time at least one semester, and if not, even after one semester they have not been able to identify an advisor, we say, take as much time as you want, right? There is no incentive for the student to delay the process of picking an advisor, right? Because their thesis would start late, so they would themselves have the incentive to pick an advisor as quickly as possible, but then they should be given enough time to identify who is the right person, what is the kind of problem they would want to work with, who is the right person to be working with on that problem. So yeah, I'm all for it, right? The students should get as much time as they can, as they need to identify a suitable advisor. In fact, to first identify an area that they want to work in, and pick an advisor in that area. How do they decide what area to work in? They will be able to decide, of course, based on the areas that they enjoyed working on, but also by doing coursework in that area, right? Because only then will they understand, the breadth of the area, the various research questions that are being asked in that area. So, at least in our department, we do encourage students to, those who have not identified a particular area, to look at many different areas, and then pick up one that they like most about, then go on to identify an advisor in the area, and then do more coursework in the area to build more depth into that area. So I would say, and this is that this should be the right way of going about it. Many other departments don't follow this approach. I think there it's fairly rigid on that the advisor needs to be picked in the first 3 months, or first within a month, or something like that.
Sometime on the day, same day.
On the same day, yes. Yeah. So that's
same
fun.
day of interview. By evening, you have to have advisor picked.
Yeah, that's like that's not even an arranged marriage. That's what's called a gun, your gun on your head, right? Marriage. Yeah. Yeah,
so that's something probably IITs need to look.
That's definitely something, and I think again, these are things. I'm sure our systems are. The systems are in place, right? In the sense that if our PhD students were to through whatever forums they have, bring this up, that this is not the way to do it, right? I think the departments, the faculty will then take notice of this, right? That this is not how it should be done. Maybe it is being done for the convenience of the faculty, right, or for some other administrative convenience. But if the students feel strongly about this, that this is they should bring this up, I think.
So there is another question which students are tormented by. Be it a BTech or a PhD student. So after, let's say they get a BTech from IITs, should they stay and do PhD in India, staying with IITs or some other institute? And same goes for PhDs who graduate with PhD. Should they consider now continuing in India, or they go abroad? So taking your own example, you're from IIT-Delhi, and BTech and then PhD. So what would be your advice? And
See, I strongly believe that, if the student has a good idea of what she wants to work on, and if that particular problem or the particular topic that student wants to work on, if the best person to work with is at place X, then the student should go to place X, whether it's in India or whether it's abroad, right? So, one should not compromise on that. So I'm not saying that you need to stay in India because of reason X or reason Y, but it's more important to it's also important to think carefully on that if you are really going abroad, what is it that you are really going abroad for. So since you brought that up, I in my own case, when I was finishing my undergrad studies, I had my PhD advisor was also a professor here at IIT-Delhi, and I had already been working on it, and that's I enjoyed doing that work. I wanted to continue that for my PhD, and he was one of the best people in the world to work on that. If he had been at some other place X, I would have liked to go to that place X to work with him. So to me, I asked this question of myself at that point. I had offers, admission offers, scholarship offers from the US, and when I was trying to decide, whether I should stay here at IIT-Delhi to do my PhD or go to, let's say, Berkeley to do my PhD, this was the most important question for me. Am I going for being at Berkeley, or am I going because I want to work on this particular topic? And if I want to work on the topic and the best person to work with is already here, why should I be going to Berkeley for that? And to me, it did not make any sense. I said, the right person to work with is here, I should be here. So I think I'm bringing that up because I think that should be, in my opinion, the defining consideration, the most important consideration, right? Because that's eventually, the kind of work that you do is going to decide your career, right? What you're going to do next, how far you are going to go. And if you want to work in an area and the best person to work in that area sits in Bhatinda, I would say go to Bhatinda to work on that, right? I hope Bhatinda is not taken as in a negative manner, but wherever it is, right, you really need to do that.
But I suppose the dilemma gets even more severe once you have a PhD, you've defined yourself, you've learned what you were supposed to learn. Now the question is, should you come back or stay in, wherever you got a PhD? So how good idea is to become a faculty in India? And because if you compare, still we may not be able to offer the best infrastructure to the incoming faculty, may not intellectually be able to contribute best of his abilities to the given institute. So that's a very difficult question for a young faculty. Should they continue in a place or start in a place which offers the best infrastructure and they contribute their best, or they take up positions in new institutes which are building nation and academic abilities of the country? So that's and you are a perfect example. In hindsight, knowing what you know now, what would you?
See, for me, this was an easy decision because, for the kind of work that I do, I don't require any infrastructure, right? I need a paper and pen, and, that's available everywhere in the world. And, the students here are as good or better than, anywhere else in the world. So for me, it was an easy decision to come back to IIT-Delhi and start my career here. About others, yeah, I can imagine there is a challenge there, right? You really need a certain kind of facilities. Maybe they are too expensive. IITs or Indian institutions cannot afford that. Then it doesn't make any sense for you to be coming back to India. But if you think that your research can still continue at a good pace by being in an institution here, that you feel confident that you can create that lab, that facilities that you need for your own research, you can do it here, then I would say, yeah, by all means come back to here. So again, my stress here would be that you are perhaps the best judge for what is it that you need to have a good research career. Of course, this decision has to be made in my opinion, it has to be made more honestly, right? One can always say, oh, I need to talk to a lot of researchers, and so I would like to stay in the US or in Europe, where I can interact with a lot of people. Those things can perhaps still be done from within India, right? That to me is not a significant constraint. If you want that, or it's not a sufficient motivation or a reason to stay out of the country. If you can still be here, and I know many people who are able to do good research while being in India and collaborating with their colleagues from around the world. So I think if you are honest that, okay, I need these resources, I cannot get these resources in this place, I need to be at this other place to get these, then it's fair, right? Then I think you have justified why you need to be at that place. But yeah, if you can do this with a clear conscience and an honest manner, I think that's fine, right? So one should not. It's important, this is a decision that every individual has likely to make based on their own individual set of circumstances, right? One cannot one cannot say that, okay, after you finish your PDF you should come back and serve India. I don't think that's the right way to do it.
Generally, students may not have the right perception. I mean, the general understanding among students is we are not asking their original questions. We are kind of repeating what the West has already done and kind of proving that. So to displace that notion among their minds, what would you, like on behalf of scientific community, maybe I'm asking too much here, what would you tell incoming students? What's the Indian scenario in terms of science status is?
I think lack of resources is only in certain areas of sciences, right? One cannot use that as an excuse for all areas of science. I think ability might also, I don't think we are, the Indian scientific community is less able than, scientific communities in other countries. I view it more as, maybe if this is indeed true, that, perhaps we have not had enough exposure to good scientific practices. This might be the case at some places. And also, maybe our models, our incentive models for faculty, for researchers are not such that they feel they should be asking big questions, that they should be trying to solve large problems, right? If you can get your salary without having to work too hard or go out of your comfort zone, for many this might this might not be, or this might be good enough reason to just continue doing what you've been doing, right? So yeah, okay, I cannot say this for many other sciences, because first I don't think I'm qualified enough. But if at all such is the case, then I think it's perhaps because it's primarily because our incentive models, what is it that our scientists feel excited about, what is it that they want to achieve. Those models are perhaps not appropriate. Those are, we need to give more to our scientists, more to our researchers, something bigger that they can look forward to if they are able to solve the big problems.
And when we talk of incentives, I mean, China has been able to do quite well in offering incentives to its scientists, and they're doing quite well, be it computer science or any other area of science. So, what is that we can learn from China other than incentive-based encouragement?
So I think one thing that China, or at least the places where I'm familiar with, or the cases that I'm familiar with in China, China has, the one model that China worked with was, to get some superstars in different areas and give them a lot of flexibility and money to do the kind of research they wanted to do. And that seems to have worked in many cases. Right, they have built large groups. They have they are producing quality work at some of the institutions where these people are. I do not know whether that's a good model for our country, but I do believe that providing scientists, researchers the flexibility and providing them sufficient resources. And we cannot do it for everyone, right? Because that's, the country is not rich enough to provide a huge amount of resources and huge amount of flexibility to a lot of its researchers. So one will have to, identify maybe a smaller set of scientists and researchers to do that with. But to my mind, that seems like a good thing to try, right? Identify the top people in a few areas and give them a lot of fixed flexibility and resources to pursue good research. That is definitely a model worth trying.
Sometimes what happens that we have to go through some coursework which is compulsory for us. So in this point, so we don't you feel that a PhD fellow should be free to choose his or her subject? Yes.
So yeah, so there is a debate on this, and in our own department too. And what I do think is that while PhD is a time to get deep into an area, it's also important to build sufficient breadth, right? Sometimes the coursework that some departments prescribe is with the intent of building this breadth, right? So in computer science, not in this particular department, but I know how things work at many other universities in the world. There is the notion of a comprehensive exam, right? Which is also there at in the PhD program here. But the comprehensive exam is usually a breadth exam. By breadth exam, I mean that the PhD student has to demonstrate that they know computers, a lot of different kinds of computer science, right? They are familiar with or comfortable with, 3 or 5 different areas of computer science. So I think that is important. Why? Because at least in computer science, and I'm sure this is also true of many other areas, once you are familiar with, what is happening here and what are the various techniques used in this and this and this, you can likely bring many of those into your own research, right? And for someone who is, let's say, working in systems in computer science, if they know about algorithms as well, then it is likely that they can use some of these algorithms to design better systems. And conversely, if someone is working in algorithms, if he has a good knowledge of systems, it's likely that he or she can design algorithms for problems in, some problem in systems, it be a caching problem or some other problem which doesn't have good algorithms, he can potentially work on those problems. Or when he's designing algorithms, he can, if he has a good system perspective, he can think of, what would be an algorithm which would work fast in practice or work well on a system. So I think it's good to have a breadth. And but I do think that the student should have the flexibility to choose courses so as to meet the breadth requirements, right. So, for instance, the way we work in computer science is that we identify, okay, these are 6 different areas of computer science, and the student has to show that they are comfortable with 3 of these 6 areas, and then they can choose any course that they want to do in those 3 areas, right. And so, while we are enforcing breadth, we are still giving the students the choice as to how they want to demonstrate that breadth. So, I think I always take the computer science department example, but we have thought of many of these things, and I am sure other departments too have, but we seem to have a solution which is sort of now acceptable to our students, and most of our students do not complain about this anymore, and also it also meets the requirements of a computer science PhD program, which we believe should have some breadth, and then of course depth within the particular area. So, I think your question was whether the specific set of courses should be done. I imagine that your department is specifying a certain set of courses because they believe that that gives you breadth in the department. If that is not the case, then again I think you should take this up, right. You should ask why are you being asked to do such courses, and whether there is a possibility of you choosing the courses that you should be doing, right. So, quite often what happens is that we are worried about that problem when we face it, but once we go past that stage, then we forget about it, right. So, but if we really care about it and we bring it up, it might help future students. And so, I think all of us have a responsibility that if we ourselves faced certain set of difficulties, we should flag it, let our whatever departments or faculty know that this is something we didn't enjoy when we were students, and that is there a different solution that can be found for these things.